Welcome to Crystal Clear Chemistry channel. In order to crack either JEE Mains or NEET exam, let's strengthen our chemistry basics through this channel. And in this video, I am going to discuss about the replica questions of JEE Mains 2025 from the chapter Ionic Equilibrium. Concepts of ionic equilibrium, I have made it in 5 parts. Check the playlist and definitely those basics will be very helpful in order to solve the problems. Okay, let's get into the first question now. The molar solubility S of zirconium phosphate with that of the molecular formula Zr zirconium 3 times and phosphate ion 4 times is given by the relation. So they are just asking about the KSP and S relation here. For sparingly soluble salts, we need to know how they dissociate. Based on the dissociation, we can write the concentrations here. If S is the solubility of the soluble salt, sparingly soluble salt, 3S will be the concentration of zirconium. And as there are 4 phosphate ions, 4S will be the solubility of phosphate ion. Then according to the KSP definition, the concentrations must rise to the power with appropriate powers, and hence here we have written 3s whole cube and 4s power 4, so that you can write the expression, final expression as a 6912 s power 7. So KSP is equal to 6912 s power 7 means S will be KSP divided by 6912 whole to the power of 1 by 7. Okay, it's a simple model but very important model. Let's move to the second one. Which of the following happens when NH4OH is added gradually to the solution containing 1 molar A plus 2 ion and 1 molar B plus 3 ions, and they have given the KSP values of both AOH twice and BOH thrice. Now listen carefully. If you look at the options here, they are asking for which among the two hydroxides, which hydroxides precipitates first. And we know already that the hydroxide with the less solubility product when compared to the ionic product precipitates out. But to calculate the ionic product continuously, as we are adding the NH4OH, the KSP with the low concentration of OH minus ion will definitely precipitates out if we keep on adding the hydroxide ion to the solution with the A plus 2 and B plus 3 ions. That is the principle here. Once again, among the given two KSP values, the one with the lower hydroxide concentration will precipitate first if we keep on adding NH4OH, because for that salt the ionic product exceeds first when compared to its solubility than the other. That is the principle involved here. And let's calculate the OH minus ion concentrations here. By knowing the concentration of A plus 2 as 1 molar, you can calculate the hydroxide ion concentration as 3 into 10 to the power of minus 5, and that of the B plus 3 and OH minus 3 is nothing but 3 into 10 to the power of minus 6. Okay, so here if we compare the OH minus ion concentrations, it is less in the case of hydroxide of B, and hence hydroxide of B precipitates out first. Okay, now let's move to the next case here. If 1 millimolar solution of ethylamine produces pH 9, then the ionization constant of ethylamine is 10 power minus 6. Then the value of X they are asking. the value of x they are asking here, and pH they have given as 10 to the power pH as 9 they have given, right? If pH is equal to 9, the pOH will be 5, then the OH minus ion concentration will be 10 to the power of minus 5. If we know the concentration of OH minus, by knowing the C value, you can able to calculate the Kb, right? You can able to calculate the Kb. How to calculate the Kb from OH minus ion concentration? Suppose if we consider the OH minus ion concentration, it is nothing but square root of Kb into C. Here say C they have mentioned it as 1 millimolar. So C is equal to 10 to the power of minus 3 molar, and OH minus C is 10 power minus 5 as discussed. That is equal to square root of Kb, nothing but 10 power minus x, into C is nothing but 10 power minus 3. If we take a square on both sides, and you will get 10 power minus x as 10 power minus 7, and hence x will be 7. See clearly, you can see the solution here, and finally we got Kb as 10 power minus 7, and hence x is equal to 7. Okay, now next one, the pH of the water is 7 at 25 degrees centigrade. What, and it's um, if the water is heated to 80 degrees centigrade, its pH will be, they are asking for the pH after heating the water. When we heat the water, no doubt the hydronium ion concentration as well as the hydroxide ion concentration increases. At about 80 degrees centigrade, the Kw value will be 10 to the power of minus 13, and hence H plus ion concentration will be around 10 to the power of minus 6.5, and hence pH will be around 6.5. That means it decreases from 7 to 6.5 when we heat the water. Okay, you can check the solution also. Anyhow, the option is 1 as the pH decreases. Next one, the Ksp for CrOH thrice is 1.6 into 10 to the power of minus 30. What is the solubility of this salt in the water? Okay, so there just they have mentioned the Ksp and asking us to calculate the solubility, and this is what type of salt? AB3 type. For AB3 type, the relation between Ksp and the solubility is nothing but Ksp is equal to 27 s power 4. From that, the s value is fourth root Ksp by 27. So here, you can clearly see the solution where we are getting the answer as the first option. Okay, now next one, arrange the following in the increasing order of the solubility products. How to come to know the solubility product? The compound which is less soluble will have the lower Ksp value. By looking at the solubility products, you can solubility product practical values. In fact, you can see that the calcium hydroxide solution is more soluble, and, hence the solubility is more for calcium hydroxide here. Apart from the practical values, how to recognize the solubility means, we know about the strong electrolytes and weak electrolytes. The strong electrolytes have the higher Ksp values, whereas the weak electrolytes have lower Ksp values. So from that perspective, you can able to write the order of increasing order of the solubility product here, and here the answer is HGS less than PBS less than AGBR less than CaOH twice. Okay, now next one. A weak acid HA has a degree of dissociation X. Which option gives the correct expression of pH minus pKa? It's not is equal to, it's pH minus pKa. So initially let us suppose that A is the concentration of HA. At equilibrium, let us suppose that X moles were decomposed. Then as X is the degree of dissociation, AX moles of H plus ion and AX moles of A minus ions will be produced, right? Then if we substitute in the equilibrium constant expression, you will get AX into X by 1 minus X, and H plus ion concentration is equal to AX here. pH minus PA, if pKa if we consider, you will get a log of X by 1 minus X. Once again here Ka expression, how to write the Ka expression? H plus ion concentration into A minus ion concentration. Yeah, let me take the white color pen here. Yeah, H plus ion concentration into A minus ion concentration divided by HA concentration is nothing but Ka. So Ka, you will get it as Ax into X divided by 1 minus X. Okay, and here H plus ion concentration is nothing but Ax. If we take the negative logarithm for the Ka value, you will get minus log Ka is equal to minus log Ax minus log X by 1 minus X. Okay, minus log Ka nothing but pKa, minus log Ax nothing but as it is the H plus ion concentration, it is pH, and finally pH minus pKa is nothing but log X by 1 minus X. Next, last one. Here, which of the following mixing of 1 molar base and 1 molar acid leads to the largest increase in the temperature? We know that whenever the neutralization takes place, the heat is evolved, that is nothing but heat of neutralization. If both the acid and base are strong, we can expect high heat of neutralization, and if any electrolyte is weak, definitely less temperature you can expect, or less heat you can expect from the neutralization. And here they have mentioned in the form of milliliters, and they have given the concentrations also 1 molar and 1 molar. That means first we need to calculate the number of millimoles of both acid and base. Both acid and base millimoles you have to calculate by using the formula m into V, where V is in terms of milliliters. More the number of moles, more is the heat of neutralization. And in the first case, this is the first case, in the case of for HCl and NaOH, we have 30 millimoles. In the case of second option, again 30 millimoles. Third option 20 moles, fourth option 25 millimoles we get. Among all the options, the millimoles are high for the first option and second option. But in the case of second option, as the acid is weak electrolyte CH3COOH, we can expect less amount of heat than the first option, and hence the first option is the correct one. Okay, for more this type of models, follow my channel and stay tuned. Thank you.